Hello, dear student. I am Amrapali Patil, Assistant Professor, Department of Physics, Mahatma Phule Arts, Commerce, and Sitaramji Chaudhary, Science, Mahavidyalaya, Varud. Uh, this is our second lecture. In this lecture, we will discuss about In this lecture, we will discuss about modes of operation. There are three types of modes of operation: common base configuration, common emitter configuration, common collector configuration. Also, we will discuss about characteristics of bipolar transistor. Depending on the configuration, there are three types of characteristics of bipolar transistor. One is input characteristics, output second is output characteristics, and third is transfer characteristics. Modes of operation. As we know, a transistor is a three-terminal device. These three terminals are emitter, base, and collector. If one of these terminals is made common to the input and output circuit, then three types of operating modes arises. जेव्हा तीनपैकी एक टर्मिनल हा इनपुट अँड आउटपुट सर्किटमध्ये कॉमन असतो तर आपल्याला तीन प्रकारचे कॉन्फिगरेशन मिळतात. अँड दीज ऑपरेटिंग मोड्स और these configurations are: one is common base configuration, which is also known as CB mode. Second is common emitter configuration, in short called as CE mode, and third is the common collector CC mode. In CB mode, as the name indicates, common base configuration, it contains the base terminal as a common for both input circuit and output circuit. Second, which is common emitter configuration, CE mode. In this, emitter is common for both input and output circuit. Also, the common third type is common collector configuration, CC mode, in which collector is common for both input and output circuit. Common base configuration, CB mode. In this mode, input is applied between emitter and base, and output is taken between collector and base. Here the base of the transistor is common to both input and output. Now see in this figure, this is the circuit diagram of PNP transistor, and this is the circuit diagram of NPN transistor. As we know, it is a bipolar junction. This is a first junction, emitter based junction. This is collector based junction. Okay, so now the first junction is input junction, hence there is a input voltage is applied, and the second is output junction where output voltage is applied. Also, this input circuit, the base is common for in this circuit diagram, the base is common for both input circuit and output circuit. You can see this base terminal is common for the input circuit and output circuit. So hence this base terminal in this circuit, this base terminal is neutral. Hence you can see this base terminal is grounded, became a grounded. Okay, similarly here in NPN transistor, the base is common for both input circuit and output circuit. Hence this base is became neutral and it is grounded in this circuit diagram. So this is a circuit diagram in the common base configuration. From this input circuit, signals are inputted in the form of input current. Then input current is going through the transistor, and then it is going through emitter to base junction, but base is neutral in nature. Hence it accept current, but it then it transferred to the collector region, output circuit. Okay, it doesn't processed or doesn't involved in the storage of input current. It doesn't stores the input current, it just accept and collect the and send transfer to the output current, output circuit. Okay, so this is the role of base terminal in the common base configuration. तुम्हाला फक्त एवढं लक्षात ठेवायचं आहे की कॉमन बेस कॉन्फिगरेशनमध्ये बेस टर्मिनल हा कसा न्यूट्रल असतो, सर्किट डायग्राममध्ये तो ग्राउंडेड असतो, तो फक्त ॲक्सेप्ट करून करंट ट्रान्सफर करण्याचं काम करतो. ओके, ना common emitter configuration, CE mode. In this mode, input is applied between base and emitter, and output is taken between the collector and emitter. Here the emitter of transistor is common to both input and the output. This is the circuit diagram of PNP transistor and this is NPN transistor. दोघांनाही कंपेअर करून दिलेला आहे. दोन्ही ट्रान्झिस्टरला कंपेअर करून आपण कॉमन इमिटर कॉन्फिगरेशन कसं आहे ते आपण बघू शकतो. ओके, नाव this is the input circuit and this is output circuit. Both the circuits contains emitter terminal common. Okay, hence this emitter terminal is neutral and grounded. Here also the input circuit and the output circuit contain the emitter terminal common and it is grounded in circuit diagram. Hence when when current is going through the input circuit, the emitter terminal it collects and transfer towards the output circuit. Okay, so this is the common emitter configuration, that is CE mode. Now common collector configuration, CC mode. In this mode, input is applied between base and collector and output is taken between emitter and collector. Here the collector of transistor is common to both input and output. This is PNP transistor, this is NPN transistor. Here also the collector terminal is common for both input circuit and the output circuit. Hence it is neutral and grounded in this circuit diagram. Here also the collector terminal is common for both input circuit and output circuit and it is grounded in the circuit diagram. This is the circuit diagram of the transistor, NPN transistor and PNP transistor, when the configuration is in common collector mode, CC mode. Okay. Now we will discuss about the bipolar junction transistor. Sorry, characteristics of bipolar junction transistor. Characteristics of transistor represents the relation between the DC current and voltages applied to the transistor terminals. The three characteristics of transistors are input characteristics, output characteristics, and transfer characteristics. जेव्हा आपण करंट आणि व्होल्टेजला वॅरी करतो, इन द ग्राफिकल रिप्रेझेंटेशनमध्ये त्याला आपण वॅरी करतो, तर ज्या प्रकारचे आपल्याला कर्व्स मिळतात डिपेंडिंग ऑन दी input circuit, output circuit, and the current flowing through these circuits, आपल्याला वेगवेगळ्या प्रकारचे कॅरेक्टरिस्टिक्स कर्व मिळतात. त्या कॅरेक्टरिस्टिक्स कर्व्सला पहिला जो इनपुट कॅरेक्टरिस्टिक्स कर्व म्हणतात, आउटपुट कॅरेक्टरिस्टिक्स, ट्रान्सफर कॅरेक्टरिस्टिक्स. All these characteristics curves defines the function or operation of the transistors. Now, first is characteristics of transistor in common base mode. In CB mode आपल्याला कशा प्रकारचे characteristics curve मिळतात ते बघू. Now, figure shows the circuit diagram for experimental setup to plot the characteristics of PNP transistor in CB mode. Common base mode मध्ये कशा प्रकारचे characteristics curves मिळतात. Okay, so this is the circuit diagram of transistor, PNP transistor in CB mode, common base mode. You can see this is a base terminal is common for this input terminal and also this for this output terminal. Okay, so it is grounded and neutral in nature. So, and when we input the applied voltage, then the input current is transferred from emitter region to base region, but base is neutral in nature. Then it transferred towards this input current is transferred toward the collector region, where it becomes outputted and it becomes a output current towards the output circuit. Okay, and during these performance we get these types of curves. First is input characteristics. One is input characteristics, and this input characteristics is depends on the input voltage, input current, and the output voltage. When the output voltage is kept constant, when we output voltage kept constant, then the graph between the input voltage and the input current, this graph is called as input characteristics curve in the CB mode. Okay, from this graph we can observe that when the value of input voltage increases, the input current is also increases. It rapidly increases. Okay, काही प्रमाणामध्ये जेव्हा इनपुट व्होल्टेज खूप कमी असतो तेव्हा आपल्याला इनपुट करंट हा 0 मिळत आहे. ओके, फॉर व्हेरी स्मॉल व्हॅल्यू ऑफ इनपुट व्होल्टेज द इनपुट करंट इज 0. Okay, but after the certain value of input voltage, the input current goes increasing rapidly. इनपुट करंट rapidly increase होता है, and during this we kept the output voltage constant. Okay, for this characteristics curve we take the output voltage constant. Okay, from this graph we can observe that the input current and the input voltage are not linear in nature. ग्राफ हा कसा मिळत आहे आपल्याला, कर्वमध्ये मिळत आहे, नॉट अ स्ट्रेट लाईन. ओके, hence the graph is not a straight line but it is in the curved line. Okay, straight line असला की त्याला आपण linear म्हणतो. the variables are in linear in nature असं म्हटलं जाते. but in this the curves are the line, the graph is in the curved line, means it is non-linear in nature, and hence we can say that in the common base configuration the input characteristics curve doesn't obey the Ohm's law. What is Ohm's law? It is the resistance equals to voltage upon current. voltage आणि करंट हे वॅरी होत आहेत, प्रोपोर्शनल आहेत, पण दे नॉट इन सेम क्वांटिटी. म्हणजे 0.5 वोल्टेज असेल तर करंट हा कितीने वाढायला पाहिजे, 0.5ने वाढायला पाहिजे. ओके, जेव्हा वोल्टेज 0 असेल तर करंट 0, वोल्टेज 0.5 असेल तर करंट पण 0.5. ओके, असं आपल्याला एक स्ट्रेट लाईन नाही मिळत आहे. ठीक आहे, जर स्ट्रेट लाईन मिळाली तर आपण समजायचं की ओहम्स लॉ ओबे होतो, बट इट इज इन कर्व्ड लाईन. स्मॉल क्वांटिटी ऑफ इनपुट voltage we get the value rapid increase of the current. Hence this is non-linear in nature. This graph is non-linear, hence it is doesn't obey the Ohm's law. From this we can observe that the impedance, that is equivalent to the resistance, the impedance of the input circuit is very small. This is the input characteristics graph in the CB mode. Now the description about the input characteristics of CB mode. From this graph we clearly indicates that for fixed collector base voltage the emitter current increases rapidly for small variation in emitter base voltage, which nearly same as diode characteristics. This means that input impedance del VEB upon del RE in common base mode is very small. A transistor remains in cutoff when VEB is less than certain small value. When BEP is greater than this value, the emitter is very small. For very small value of input voltage we get the cutoff, means the zero value of input current, and as the input voltage increases we get the very small amount of input current. Here the emitter current is nearly independent of collector base voltage. Hence collector current is almost independent of collector voltage. Input impedance is denoted by HIB in CB mode. You should remember that input impedance in the CB mode is denoted by HIB. H for the input impedance, I for the input, and B for the I for the input characteristics, and B for the common base mode. Okay, so here emitter current is independent of the uh, output voltage, and the output current is also independent of the output voltage. Okay, so this is the description about the input characteristics in CB mode. Now, second characteristics curve is output characteristics, and this output characteristics is depends on the output voltage, output current, and the input current. Here the input current IE is kept constant. These are the constant value of the input current. When this input current is kept constant, the variation between the output current and the output voltage is measured, and the graph is plotted against the output current and the output voltage. This graph is called as output characteristics curve. Okay. Now in this graph, where the output current and the output voltages have their positive values. This is the first quadrant of the graph, where the output current and the output voltage all have the positive values. Okay, so this region, this area is called as active region, and you should remember that all the transistors are performed only this active region, where the output current and the output voltage have their positive values. Okay, now in this output region we can observe that for the increasing value of the output voltage, the output current is constant. It is constant. For the 5 volt of input voltage, we get this value of input current. For 10 volt of output voltage, we get the same value of output current. Okay, by keeping the input current constant. Okay, so this is the active region, where all the output current and the output voltage are positive in nature, and this region is called as active region, and all the transistors, most of the transistors performed in this active region. Okay, now there is a cutoff region, where for the particular value of output voltage, for the particular value of output voltage, the output current becomes 0. This region is called as cutoff region. This region is called as cutoff region. Okay, this is a very small region. We cannot see in this diagram, but the definition of the cutoff region is the region in which the for the certain value of output voltage, the output current becomes 0. This region is called as cutoff region. Okay, now this region, look at the figure. This region where the voltage has their negative values. Okay, the value left to the 0, and this region is called as saturation region. Okay, for the negative values of the output voltage, we get the certain value of output current, and this region is called as saturation region. So in the output characteristics curve of the Uh, CB mode configuration gives the three regions: active region, cutoff region, and the saturation region. Okay, active region is most important for the output characteristics. Now, the description about the output characteristics in the CB mode, which clearly indicates that output current IC is the output current is constant for variation in output voltage above 0 volt. This region is called active region. The transistor always operates in this active region. When used in amplifiers, the cutoff region is defined as the region where value of collector current is 0. The region where the value of collector region is 0 is called as cutoff region. The saturation region is defined as the region to the left of the output voltage equals to 0 volt of the characteristics. The ratio of the small change in collector current to the corresponding collector base voltage means the ratio of the small change in the output current and to the output voltage at constant emitter current is input current, gives the value of output admittance. Okay, to get the output admittance we get the ratio between the output current to the output voltage, keeping the input current constant. Okay, output admittance we get. So output admittance is equals to slope of the output characteristics. When we calculate the slope from this diagram or graph, we get the output admittance. Hence, the output admittance is equals to slope of the output characteristics, and output admittance is nothing but the reciprocal of the impedance. Hence, we can write as del IC upon del VCB equals to HOB. HOB is the HOB represents the output admittance in the CB mode. So this is output characteristics in CB mode. Now, current transfer characteristics in the CB mode. This is the curve which shows the variation of output current with the input current for constant value of output voltage. Okay, जेव्हा आपण आउटपुट व्होल्टेज कॉन्स्टंट ठेवू आणि आउटपुट करंटला इनपुट करंटशी जेव्हा आपण व्हॅल्यू करू, जो कर्व आपल्याला मिळतो, जो ग्राफ आपल्याला मिळेल त्याला करंट ट्रान्सफर कॅरेक्टरिस्टिक्स कर्व असं म्हणतात. Okay, so from this graph we can observe that by keeping output voltage is constant, and for the increasing value of input current we get the increasing value of output current. Okay, जेव्हा input current हा 0 आहे we get the output current 0. For 2 value of input current we get the 2 milliampere current of output current. Okay, जेवढ्या प्रमाणात आपण इनपुट करंट इनपुट करत आहोत तेवढ्याच प्रमाणात आपल्याला करंट हे आउटपुटमुळे आउटपुट सर्किटमधनं मिळत आहे. ओके, सो द ग्राफ इज straight line. The graph gives the straight line which indicates that the current, input current and the output current are proportional to each other. Okay, They doesn't increases rapidly. The output current doesn't increases rapidly, but increases with respect to the output current increases with respect to the input current. Okay, जितक्या व्हॅल्यूनी इनपुट करंट आपण जितक्या व्हॅल्यूनी आपण इनपुट करंट आपण इनपुट करत आहोत, सेम व्हॅल्यू आपल्याला आउटपुट करंटमध्ये मिळते. ओके, अँड जेव्हा आपण स्लोप काढू तर आपल्याला काय मिळेल? ट्रान्सफर करंट रेशो. We get the transfer current ratio. Okay, so the description about the transfer current ratio characteristics curve is: by keeping output voltage constant, change the emitter current in steps and note the corresponding value of collector current. Plot a graph between emitter current and the collector current as shown in figure. This is the transfer characteristics of transistor in CB mode. This curve gives the transfer characteristics of transistor in CB mode, which nearly linear. The graph is linear, means we get the straight line, which the ratio of small change in collector current to the corresponding change in emitter is known as forward current transfer ratio. The ratio between the emitter current to the collector current is called as forward current transfer ratio. So the forward current transfer ratio is equals to del IC divided by del IE, means the del change in the output current to the change in the input current. It is denoted as HFB. H for the forward current transfer ratio, and F for the this current transfer ratio is forward in nature, and B for the common base mode. And this is nothing but this value gives the slope of the transfer characteristics. So students, in this lecture we have discussed about the modes of operations in transistor and the characteristics of the transistor. I hope you understand the topic. Thank you.